Okay, calculus, example number 2. We are going to find the area bounded by these two parabolas, 4 minus x squared, that opens down, 4x minus x squared, and the y-axis. So it's this shaded region right here. Remember, we put in a rectangle that hits both functions, no matter where you put it. So I can put in a vertical rectangle anywhere in this shaded region, and it will hit both parabolas. I can't put in a horizontal one because I could put it way down here, and it would never hit this function. So vertical rectangle. So our goal is to set up a definite integral, which looks like this. You need a function, and you need your limits a and b. To get your function, you subtract your equations. It is always the higher y-value function, the top of the rectangle, minus the lower y-value function, the function at the bottom of the rectangle. Remember, the top of the rectangle here, if you key in on that y-value there has a higher value than the y-value down here at the bottom of the rectangle. All right? So let's do that right now. For our integral, we take the top of the rectangle function, 4 minus x squared, minus the bottom of the rectangle, 4x minus x squared. So we have 4 minus x squared, and then don't forget that second one has to be in parentheses, 4x minus x squared, because you have to remember to distribute. All right, so now we simplify. So we distribute the negative. So 4 minus x squared comes down. We get negative 4x. And then we get positive x squared. All right, and we need a dx on the end, of course, for good calculus notation. And now we just add like terms. So it's going to look like this. Check this out. Negative x squared and positive x squared, they cancel out. So we are left with negative 4x. And then we have plus 4. So there is our integrand. That is the equation for our definite integral. So remember, you subtract your equations. If it's a vertical rectangle, it is the higher y-value function, the top of the rectangle, minus the lower y-value function, the function at the bottom of the rectangle. Don't forget to put that second function in parentheses, distribute the negative, and add like terms. Now we just need the limits a and b. So to get your limits a and b, you always set your functions equal to each other. So we take the two functions, 4 minus x squared, and we set it equal to the other function, 4x minus x squared. All right, to get all the x squareds together, I'm going to add x squareds to both sides, and as you can see, the x squareds cancel out. So I'm left with 4 is equal to 4x. If I divide both sides by 4, I have x is equal to 1. I'm only given one limit. So if that happens, you'll have to get the second limit by looking at the graph. All right? The farthest part of this shaded region, right here, the x value is 0. All right? So that's the farthest part of the region on the left. The farthest part of the region on the right is right here. And if I scroll down, that y value is 1. So we are going from 0 to 1. I just had to use the graph to get our left limit. So we add those in right here from 0 to 1. And that was our goal, to get a definite integral to find the area of that shaded region. Now we solve this using the fundamental theorem of calculus. The first step is we find the antiderivative, g of x. So this is just going to be two power rules. This antiderivative is negative 4, comes along for the ride, x to the second over 2. This is the same as 4x to the 0, even though we don't write that, because anything to the 0 power is 1. So to use the power rule, we get 4x to the first over 1. We add 1 to the exponent, and we put the same number on the bottom. And remember to use a bracket to bring along your limits. All right, let's simplify that. So g of x, that first term right here, negative 4 divided by 2 gives me negative 2x squared plus 4x from 0 to 1. There's your antiderivative. First step of the fundamental theorem of calculus to solve a definite integral. Okay, second step of the fundamental theorem of calculus is we simply plug in our limits into the antiderivative. The top of the rectangle, g of 1, minus the bottom of the rectangle. The right endpoint minus the left endpoint. So put your antiderivative into y equals in your graphing calculator, go into your table and find the value at 1. Go ahead and do that right now. When you plug in 1, you should have gotten a whole number 2. And when you plug in 0, you definitely get 0. So our area is 2 units squared. There you have it. That is how you set up a definite integral to find the area between two curves. Thanks, calculus.